What's up, everyone? In this video, we're going to teach you all about regression analysis with the Ti-84 calculator and Google Sheets. So let's do all that with a very simple problem. And the problem is this: an experiment was done to determine if you put more detergent, soap, essentially liquid soap, into a pan, will you get more soap suds? Does more detergent cause more soap suds? So we took several pans, all the same size, all the same amount of water, and each pan we put in some detergent. One pan got 4 grams, 4.5, 5, 5.5, 6, 6.5, and 7 grams detergent. We agitated every pan the exact same way, trying to make sure that we treated every pan equally. And then we measured the heights of the soap suds that got created from that agitation. And you could see, for example, the pan with 5 grams of detergent had 45 millimeters of sud height. So our goal was to determine, does this experiment show that more detergent means more sud height? So let's first show how to do this on your Ti-84 calculator. Now, I don't want to say your Ti-84 calculator is limited by any means, but it just doesn't make things look very pretty. But it is the only tool that you are allowed to use on the AP Stats test, so it should make sense you know to do it. So first, make sure, as always, you hit mode, and if you hit up, make sure you have stat diagnostics turned on, stat wizards turned on as well. If one of those things is turned off, then your screen might not look exactly like mine. So as always, if I'm going to explore some data, the first thing I'm going to do is hit stat edit to enter the data in. List 1, I put the different amounts of detergent, 4, 4.5, and so forth. And then in list 2, I put the corresponding sud heights. So please double check that you type everything in correctly. Last thing you want to do is type in something wrong. And just make sure the data is correct. All right, so the first thing I'm thinking I would like to do is take a look at a scatter plot just to see what's happening. Is a linear model even appropriate? Starts with looking at a scatter plot. So to do that, we're going to hit second y equals, go to our stat plots, turn plot 1 on. Make sure the little scatter plot is selected, and make sure that your X list is L1 and your Y list is L2. That is, of course, where we entered our data. If you did enter it somewhere else, just change it to the appropriate list, 3, 4, 5, 6, whatever. And then when you're ready to go with that, I usually quit out of there and hit zoom. This is the key thing a lot of kids forget. Zoom number 9. This is your zoom stat. Anytime you're doing anything with that stat button, you want to hit a zoom 9. And notice I have a graph going through there. So the first thing I'm going to do is go to y equals. And yeah, I had a quadratic typed in there, maybe from another class. So we want to clear that out and make sure that that is good to go. We don't want something in there that's going to mess with that graph. All right, and hopefully your scatter plot looks something like this. And again, make sure that nothing's in that y equals. Sometimes that'll make it look weird. So if I'm just looking at this, I'm thinking, wow, yeah, this looks pretty linear, positive, pretty strong. And of course, I do see what exactly I was hoping for was that, if you increase the amount of detergent that you put into a dishpan, you are more than likely going to increase the suds height of the suds in that dishpan. But now I actually want to find my linear regression model. This is where the Ti-84 calculator is actually better than what I'd say Google Sheets is, because Google Sheets kind of do things in a slow, meticulous manner, whereas Ti-84 calculator makes it pretty nice. We're going to hit stat, slide over to calc, and we're going to go to number 8. Remember, we like to use A plus BX. In statistics, A is the y-intercept and B is the slope, so we like to use number 8. Once again, make sure you have the data in there correctly, list 1, list 2. Now, one cool thing you can do here is it says store the regression equation. So once you have the equation, you could go to y equals and type it in. That way you can actually see it on top of your scatter plot. But this actually gives you the option of doing that automatically for you. So I'm actually going to store the regression equation as y1. That way it's actually on my graph. So to do that, you're going to hit the vars button, V-A-R-S. You're going to slide over to y-vars, and then number 1 is function, and that is where you can grab y1. So I'm basically telling the calculator to store the function in y1. You do not have to do this, but it's kind of nice. That way you can see it on top of your graph. All right, whenever you're ready to go, everything will be there. Look how fast that was. This is awesome. So this means that our equation is y hat equals negative 0.857 plus 9.143 times x. So again, I always like to go with 3 decimals, okay? R squared is 0.960. R is 0.980. So pretty awesome here. So, you know, this right here just tells me a ton, right? So let's talk about this real quick. So the R tells me how strong this is. My scatter plot was definitely linear, so it was the right move to use a linear model for sure. It's positive, which means it's going up, like we said. And then the R squared, remember R squared is an awesome value because it actually tells me how connected these two variables are. So R squared is a percentage. So that tells me that 96% of the variability in sud height is actually determined by the variability in amount of detergent. So the 96% of the different sud heights that we have in our data are actually determined by the variability or the different amounts of detergent we use, which is, you know, showing how strongly connected these data is, right? So again, remember, I did type this into Y1, so it automatically went there. And the cool thing is it uses all the decimals. So it's going to be really exact. It doesn't round anything at all. Now, when I hit back to graph, you can actually see the line go through there. Now, this is probably the coolest thing. When you run the stat, I'm going to do it again here, stat number 8, when you actually do this, okay, and I don't have to store the regression equation again because I already stored it there. The moment you do that, without even telling you, the calculator automatically makes a list of all the residuals. It does it automatically. In fact, every time you do a linear regression, it automatically updates the residual list to that most recent entering of data. So if we go under stat, and then, I take that back, second stat, which is a list of lists. So again, right above stat, it says list. So second stat is a list of lists. You will see that there is always, it's just kind of like always sitting there, is a list called resid. And every time you run a regression, it's going to automatically change that list to your most recent data that we entered in. So right now, since the last thing I did was that regression analysis for this data, right now, this residual list, I can actually click on and take a look at it, is a list of all the residuals. Like it's automatically done for me. So the very first data had a residual of negative 2.7. The second value, again, you could scroll right or left to go through this list, was 2.21. So it's pretty cool. Now, it doesn't make a list. So when we go stat edit, it doesn't actually make a list of them here, but it is stored in the calculator as that residual list. Okay, again, it's under second stat, second list, and then it's right there, number. It depends how many lists you have, but it's there. Trust me, sometimes you got to scroll down for it. So now this allows me to now make a residual plot, right? So now I'm going to go back to second y equals here. I'm going to go back to plot 1, okay? And this time I'm going to leave the x list alone, and I'm going to change the y list to my list of residuals to make a residual plot. So again, to do that, I'm going to hit stat. Whoop, I take that back. I'm so sorry. Second stat to get to my list of lists. And then I'm going to go and grab that residual list, okay? And you can't type it in. You can't like type in RESID. You actually have to go here to get that list of residuals. So there it is. So now I'm looking at my X's, which was the amount of detergent versus residuals. And again, now I'm actually going to go back to y equals and clear this out because I don't want, I don't want that line interfering with my residuals because it's obviously different. And then again, because I did change the data, I'm going to do a zoom 9 and look at that residual list. A residual plot. This is a beautiful residual plot. I got positive residuals in the beginning and in the middle and in the end. I got some negative residuals. I don't see anything at all. And this is a good sign that my linear regression model is truly going through the data. So that is a really quick way that you could run through your calculator and pretty much find everything you need. I mean, it's pretty simple, pretty self-explanatory, but that residual plot is nice because it allows you to know how appropriate your data is. Again, it's automatically created for you every time you run that linear regression. So it's pretty cool. All right, so we got the equation. Y hat equals negative 0.857 plus 9.143x. Again, that came from when I did that stat linear regression number 8, a plus bx. And obviously, it's important that you know how to interpret those values. So I'll just kind of say this out loud real quick. So the y-intercept tells me what I expect the sud height to be with 0 grams of detergent. So the y-intercept is negative 0.857. It says if you put 0 grams of detergent into a pan, we would predict that you get negative 0.857 millimeters of set height. Well, obviously you cannot have negative millimeters of set height. And like we talked about in the lesson, is sometimes the y-intercept doesn't make a whole lot of sense at all. And that's really totally okay. It's part of the equation. It doesn't really have to make sense. But the slope definitely makes sense. The slope tells me that for every 1 gram of detergent that I add into a dishpan, I predict the height of the suds to increase by 9.143 millimeters. So add a gram of detergent, you're gonna, it's predicted to get 9.143 more millimeters of height on that soap suds. All right, so now let's go to Google Sheets and teach you how to basically do all of this in Google Sheets. All right, it's pretty simple, pretty cool, but it just takes some steps. So the first thing I'm going to do is I'm going to go ahead and get that scatter plot. So I'm selecting all of my data, insert chart, and it usually jumps straight to that scatter plot. For some reason, if it doesn't, you could go under setup and change this. So I'm going to quickly adjust my screen here because I just realized that you cannot see quite everything. And that's the last thing I want you to be able to see everything. Okay, so under setup, if it doesn't pop up as a scatter plot, you can grab it right there. All right, pretty much we see that same scatter plot we saw in our calculator, just a lot prettier. We see the axes are labeled. We actually see the values, much, much nicer. Now, one cool thing that you could do here is under customize, if you go to chart style, we can, change different colors, change different things if we want. You could change the axis titles. You can change a whole lot. A lot of different things that you could do here. Okay, but under series, if you click the little drop-down menu for series, this is kind of cool here. What you could do is you could actually click to add in the trend line, which is, of course, the line of best fit, the least squares regression model. So that's kind of cool. So you can actually line it in. And then you've got to scroll down a little bit more. You could actually have it label that line. Right now, the label is set as none. You can actually label that line using the equation. And then you'll notice the equation actually pops up. It's kind of small, but it does pop up. 9.14x plus negative 0.857. So it is in the opposite order, but it is true, right? Whatever number is being multiplied by x is your slope. So my slope is 9.14, just as we said. And then the other value is the y-intercept. It just doesn't do it in that a plus bx order that we like, but it's still the same equation, just written in the other order. But that's okay. And you can actually click show r squared, and it'll show r squared as well. So that's one cool way that you could get the equation pretty quickly there. I'm going to show you a different way here in a moment, but that's one way to do it. All right, now let's talk about getting kind of all the values you need. All right, the first thing we need is the correlation. And you have to just grab a box and hit equals, all right? After you hit equals, you can start typing CORR and you'll see correlation pop up. Now to get the correlation, we have to select our X data, do not select the title, comma, select the Y data, and then hit enter, and boom, there is that value, 0.9800, that again, we also got on our calculator. So I'm gonna label that as R. And I'm going to make all of these a little bit bigger. That way they stand out a little bit more. And again, if you want to shrink the decimals down on this, if you highlight that box, you see that you can add more decimals or shrink decimals. So I'm going to dial that back a little bit there. Okay. What else do we need? Oh, the slope. So we just hit equals and then start typing SLOP and it pops up, slope of a regression line. So once again, we're going to select the X data, comma, the Y data. Hit enter, and there it is. Whoa, that's not it. Hold on one second, let me figure out what I did wrong there. I'm sorry, you have to do the Y first, then the X. Remember R, this is a good little lesson here. R doesn't matter who's X, who's Y. Doesn't matter. You could put them in any order, and you're gonna get the same correlation. But slope, equals, and then start typing slope. This does want the Y's first, so I'm gonna select the Y's first, comma, then the X's. So you got to be very particular with that. And again, another reason why I actually like the calculator better, because it just gives it to you. You don't have to worry about any of that stuff. And then again, label that as slope, and I can knock down the decimals there if you want, a couple there. All right, then we also need the y-intercept. So I'm going to go and grab equals. Now, in the world of stats, it's not actually called the y-intercept. It's just called the intercept. Like, it's common sense that it's the y-intercept. So we're just going to type in intercept. And you don't need the y. You can just intercept, and you'll see y-intercept of the regression equation. And then once again, y's first, comma, x's. And then you'll get that y-intercept. We could shrink down some decimals there. And let's label that as the intercept. All right, so pretty cool. So then you can actually put that together on your own to create the equation, right? Y hat equals negative 0.857 plus 9.143 times x. So nice and simple there, everything you need. Now another value that you might want is r squared, but come on, you already have r 0.98. Doesn't really take a whole lot to just take that value and square it, so that's pretty easy to do on your own. Finding the standard deviation of the residuals. Now, it's kind of a tricky number. We talked about it in class. It's kind of got an ugly formula. 99.9% of the time, you're just going to be given that S value, and the goal is really to interpret it. But you can find that value here on the Google Sheets. We're going to hit equals. Start typing standard deviation, ST. Now, here's the thing. Just type in ST, and then you're going to see standard deviation. And it's this one right here. It's called STEYX. This is the standard deviation. Now, they actually list it as the standard error of predicted Y values in a regression. That's kind of like the official name of it, but most people just call it the standard deviation of the residuals. But it's really the standard error of those predicted Y values. So we're going to grab that one right there, and then again, select the Y values first, comma, then the X values, and there it is, 2.194. You could shrink down the decimals on that. Now, this is the one thing your calculator does not give you, S, the standard deviation of the residuals. Whoop, it's accidentally typed in slope there. Sorry about that. The formula is a little bit tricky. Like some kids will say, well, why don't I just take the list of the residuals, right? Remember, on your calculator, it automatically creates a list of residuals. Why don't I just find the standard deviation of that list? It's a little bit different. It's really close to that, with just with a couple little minor things that are different. So it's not quite as simple as just literally find the standard deviation of your residuals. That's just because the formula is a little bit different. Like I said, it's not a huge deal right now. What I actually care more about is that you know how to interpret that number. So the standard deviation of the residuals is measured in the Y. So that's millimeters. So that 2.194 is in millimeters. And what this tells me is that when I use this line, this blue line that you see, when I use this model to predict the height of subsets, I'm typically off by 2.19 millimeters, right? That's pretty small. I mean, when you're working with millimeters, and if you're off by 2.19 millimeters, that's pretty good. Now, look at the data, right? The data range from like 33 millimeters to 61 millimeters. So if you're making a prediction and you're only off by about 2 millimeters, you know what I mean? That's pretty good. Now, it's all in context, as we talked about in the lesson. Standard deviation of the residuals, some people could say 2.19 is a big number, or others could say it's a small number. So you really have to look at your data. And in terms of my data, the subsets 33 to 61, if I'm off by 2.19 millimeters, that's not that big of a deal. Now, if I'm measuring, bumblebees, and bumblebees themselves are only like maybe 10 to 15 millimeters long. Okay, if you're measuring bumblebees that are only 10 to 15 millimeters long, and all of a sudden you're off by 2 millimeters, that's actually a lot. So it's all within the context of your problem and your numbers. So keep that down, right? Make sure that you understand that. So in terms of for this data, that's actually a pretty small standard deviation, which means that when I do make predictions with this line, I'm typically pretty accurate. And you can actually see that just by the fact that the points are, for the most part, really, really close to the line with very, very minute residual values, okay? So pretty cool. I think we narrowed down every little detail that there is there that the calculator and the Google Sheets could do for us. Pretty cool tool. And then you have to do all that explaining. You have to do all that interpretation. But hopefully we ran through enough that you could find everything you need with Google Sheets, and then you can also do everything you need on your Ti-84 calculator. All right, awesome.